The reason we're going to all this trouble to learn how to identify a binomial probability experiment is that if you have a binomial probability experiment, then there's a formula you can use for the probabilities. In other words, you don't have to write out the sample space and count items in the sample space to determine your probabilities. The formula is here. P of x equals n combinations of x. That's what that NCX notation is read as. And by the way, we'll learn more about that later in the semester. But for now, n combinations of x, all we need to know is how to calculate it. And I'm going to show you how to do that. Then times p to the x power times 1 minus p to the n minus x, where p is the probability of success in any one trial, and as usual, n is the number of trials. So, how do we do that? I'm going to show you how to do this on a TI-30XS calculator. That's the one I recommended in the syllabus that you get because that's the one I use to demonstrate things. So, given a binomial experiment with n equals 10 and p equals 0.8, let's compute p of 3, and then we'll interpret the result. Notice that this 3 is telling us what x is. So this 3 right here means use 3 for x. So plugging into our formula, p of 3 would be, I'm going to replace the n with a 10, the x is a 3, and then I have p, which is 0.8, raised to the power x, and again x is 3, times 1 minus p, so 1 minus 0.8, to the n minus x power, so to the 10 minus 3 power. Now before we enter this in a calculator, we should do a little bit of simplifying. Basically, here where we've got these subtractions, let's go ahead and simplify those. So at this point we have p of 3 is n combinations of 3, 10 combinations of 3, 0.8 to the third power, and then 1 minus 0.8 is 0.2, and of course 10 minus 3 is 7. So now let me show you how to do that on the calculator. Here we go with calculating. First, I'm going to make sure my calculator is turned on. Then I put in the 10. Then we go to the PRB menu. I'm going to use my down arrow so that NCR is selected. I hit enter. Then I'm going to put in my 3. Then we're multiplying by 0.8. Now the 0.8 has to be raised to a power, and we use this little up arrow for that. The power is 3. Now notice how the cursor is up there in the exponent. Okay, we don't want it there. So I'm going to use my right arrow to move it over. Now I'm multiplying by another thing, and that thing is 0.2. Now the 0.2 is also raised to a power. So I use my power button, and I put in the power 7. Now the cursor is still up in the exponent, but since we're at the end of the calculation, we can just hit enter and it'll know that's what we want. Next, I'm going to show you a slightly more streamlined way to do this calculation. 10 and I go into the probability menu. Now, instead of using the down arrow to get the NCR highlighted, I can just hit 2, and that knows I want menu item number 2. Then I put in my 3. Now we're going to multiply by 0.8. I want to raise that to a power, so again I use this caret key. The power I want is 3. And then again, notice that our cursor is blinking in the exponent. I don't want to multiply the exponent by something. I want to multiply the whole expression by something. So I use the right arrow to get out of the exponent. Then I do times. And we're multiplying by 0.2 raised to the power 7. Now again, since we're at the end of the calculation, even though the cursor is up in the exponent, we can hit enter. But if you feel more comfortable and you want to get that cursor out of the exponent, you can use the right arrow and then hit enter. And we'll get the same thing we did before. So we've determined that P of 3 is 0.00786432. But what does that mean? Let's interpret this result. This tells us that in a binomial experiment, with 10 trials and probability of success in each trial let's say it this way, and an 80% probability of success in each trial. The probability of getting exactly 3 successes, and of course that's out of the 10 trials, that probability is, and I'm going to write this as a percent again because that's a little more intuitive, is 0.7, let's round off to 9 there, %. So a little bit less than 1% probability of getting exactly 3 successes out of our 10 trials.